Yeah. Okay. Cool. So, ready to start. So, the rubric just basically states that we need to do a problem similar to the last problem we did in class, with wires running in either the x direction or the y direction, but not both. So we don't have to worry about it going, too many different ways. So we either had to have three wires or 4 wires. I mean a 4-wire one, so we could compare the ones from class and this one. Can everybody see what's written up here, or is the light being off affecting it? Not getting any response, so I'm just gonna leave it up. Okay, cool. So I put 4 wires going in the on the x direction. 5 amps going to the right, 3 amps going to the left, 6 amps going to the left, and 2 amps going to the right. The 2 far wires are 5 meters apart. The 2 middle wires are 1 meter apart, and then these wires are 2 meters apart, and these are 2 meters apart. Just in case you can't see that and need it all down. So, probably the best thing to do to start is just going through each wire and determining what its its magnetic field is above and below the wire. So we know for each one how it will affect the other ones. So, starting with the top wire, what direction will it be going at the top? Yeah, out. So out of the page. So I'm going to do this plus C. So up here it's going to be plus C for this wire. And that means below it, it will be minus C, or going into the page. So minus C.
Can you show us how you did that?
Yeah.
I was totally had it like that, and it was going in and coming out.
Yeah, okay. So have your thumb pointing this way. You can have your hand flat. As it's curving around it, it'll be going at the top.
Right hand.
Use your right hand.
Were you using your left hand?
That's what Jack
There's a reason that it's called right hand rule.
I was just
And okay, so now that we have that figured out, make sure you're using your right hand. If you're using your left hand,
no
you're
matter
probably
which
doing
way
it.
the arrow's pointing, you're
Always
pointing
using your right hand.
Okay.
Okay, cool.
Yeah, that's the problem.
Yes. It's called right hand rule for a reason, and you use right hand every time. Okay, cool. So going the other direction, what's happening on top? So this 3 amp wire, what's the direction on top? Negative Z, yes. So minus C, which means on bottom it is plus C. Yeah, it has to be exactly the opposite. And so what about the third one? So on the top, it should be the same as the one above it, since they're going in the same direction. So it'll be negative Z on above it and plus C below it. And what about the bottom wire going the right hand direction? Yeah, so it'll be the same as the top one, where you have plus C on top, minus C on bottom. For this one and this one, we don't have to worry about the things going all the way above this and all the way below this. I just did it so we could go through all of them the exact same way. So, to find the magnetic field acting on each wire, you're going to have to basically sum all of the magnetic fields from each of the other 3 wires. So, to give an example of that, I'll do the first wire, which is the top one. I have these labels 1, 2, 3, and 4. So the top wire, which is 5 amps, is being acted on by this 3 amp wire, the 6 amp wire, and this 2 amp wire. So I think it's probably best just to know anything that has a negative Z magnetic field is negative, and anything that has a positive magnetic field is positive. That way, when we're done, if it's a negative number, the magnetic field is obviously negative Z. And if it has a positive number, then it's positive Z. Does that make sense? I hope so. Okay, so for the 3 amp one, you'll have 3 amps times K prime over 2 meters. It's a 2 meter difference there. And that is in the, that'll be negative because above the 3 amp wire is negative Z magnetic field. Okay? Similarly for the magnetic field caused by the 6 amp wire, you'll have negative, since it's negative Z on the top side, 6 amps times k prime all over 3 meters. Cool. And then for the bottom one, it's going to be positive z above it, so acting on the 5 amp wire will be 2 amps times k prime all over 5 meters. So at this point, you could basically, I'm just going to let you guys know that you don't really have to include k prime in this example because k prime is going to be consistent throughout all of them. So I'm just including it so you remember to use it in all the equations. Yeah.
I can't see the writing now because of the light.
Okay.
Like the better.
You want to turn the light on back there, or right here? I don't know which one. I think it's that one. Okay.
Yeah, I
Eh,
don't know.
They can see it. They'll get it. You can pause the video. It's totally fine. Okay, so if you add all these up, we'll end up having, like 3 halves k, or negative 3 halves k minus what would be 2 k prime plus 2/5 k prime. So what you'd actually end up with is something like negative 3.1 k prime. It really doesn't matter what the actual numerical value is. It's more important that you know that it's negative. So that means it's in the negative z direction. That is the magnetic field. So on wire 1, B will be in the negative z direction. Okay. So I'm just going to determine which way that it'll deflect using that. So if your velocity is going in the right hand direction and your deflection is negative z, or going into the board, your deflection will be up. Everybody get that? Okay.
From where?
The top wire. So the top wire we just determined has negative z magnetic field, and the velocity is going to the right, as he explained in class. You have essentially positive charges going all the way down that wire in that direction. So velocity, I guess I should do this here. Velocity curve into the board, thumbs pointing up. That means the force on that wire will be up, or the deflection. Cool. Okay. So we'll do the same exact thing for all other 3 wires now. Does anybody have questions before we do it?
How did you know the velocity was going to the right?
Yeah, so the direction of the current is the velocity in this case. Yeah, it's basically just infinite positive charges going in that direction. Towards the board? This negative z? Okay, so yeah, that's how it's towards the board. Yeah, negative z. So in this case, it's always positive z or negative z. There's only 2 possibilities because just of the way that wires are oriented. So okay, so are we ready to do the second one?
Yeah.
Okay, second one. Here we go. 2. All right, so the first one we can say. So now we're doing the wire 2. So force, the magnetic field of at wire 2 caused by wire number 1 will be below this is negative z. So negative some number, which will be 5 amps times k prime over 2 meters, which is the distance between them. Who can tell me what the next quantity will be from the third wire? Yeah, so also, negative z, as you can see above it, since it's acting on the 2 wire, is negative 6 amps times k prime divided by what is 1 meter, so that would be a full 6. And then what about the fourth wire? Plus, yes, perfect. So plus z above it, so plus 2 amps times k prime all over 3 meters. 3 meters. Okay. And if you end up summing that up, you should get, I can't remember what the value was. Negative 7.5. Okay. You get a negative, so that equals negative 7.5 k prime which is a negative value. So once again, that means the field is in the negative z direction. And that is what is important. So now we can once again determine the deflection of the wire. So in this case, your velocity is now going in the right-hand direction, and your magnetic field is in the negative z, so you'll have to turn your hand like this. So velocity is going this way, magnetic field's curling backwards, your force will be down.
It looks like you're using your left hand on the video.
Well, I hope they can figure that out.
It's kind of funny.
Well, we figured out it is
You're
right.
good, you're
Okay,
good.
so deflection of the force will cause it to be in the downwards direction. So when I'm writing force, it's just like the deflection force is not actually. There's a force, but we didn't make a numerical component. Yeah, component. That's not important for us right now.
So you like point your hand in the direction that the arrow's going.
Yes.
And you determined by looking at like the b or like the field equals negative z is depends on like which way your hand's turned.
Yeah.
And then that gives the force.
Yep.
Yeah, that gives the deflection. That's it. Yeah, it's better. So now that we're going slower, I think everyone's gonna get this. Okay, who wants to help on the third one? So what will be the first value?
5A, K prime, 3 meters.
Okay, so yeah, negative 5 amps, K prime, 3 meters. Yes, that is exactly right. So that would be the first one. So once again, negative z on that one since it's below the first wire. What about from the second wire? Second wire acting on the third wire will be
Negative 3A.
plus 3a. So below this 3 amp wire is plus c. Magnetic field's in the plus c direction. So plus 3 amps times k prime divided by 1 meter, because that's the distance. What about the fourth wire acting on the third wire? Plus, perfect, plus what? 2 amps divided by 2 meters. 2 amps K prime. And that equals what? Like 2.33 or something like that?
Yeah.
2.33, yeah, 2.33 K prime. And since that is a positive value, our B, I'm about to go off page. Okay. Our B value of that is going to be plus Z. Okay, so now we can determine deflection. Once again, our hand's going in the direction of the velocity to the right. This time, it's in the positive z direction where the field is, so we're curling towards that field. Force is up. So force is up. Okay. So doing well. Okay, cool. Fourth. Last one. Okay. So first one will first wire acting on the fourth wire, what will it be? Yeah, negative 5A divided by 5 meters. So negative 5 amps K prime divided by 5 meters. What about the second one? Sorry, say that again.
Plus 3A.
Yeah, plus 3A. Plus 3 amps times K prime. Oops. 3 amps times K prime over 3 meters. And what about the last one? Plus or minus? Plus. Plus 6 amps K prime over 2 meters. So that'll equal what? I think it should equal 3. So it ends up equaling 3K prime, and that's in the positive direction, so our B field is positive Z. Cool. And deflection now. So going this way is our velocity. the direction of the field is positive z, so out of the board, so we'll have to turn our hand over. Curl towards going out of the board, forces down. So, there we go. Found everything we wanted to know. Forces in down direction. Cool. So there you go. We found all of the magnetic fields at all the wires and for the deflection directions of all the wires. Cool. That's all we had to do. So now we need to make another one. So go ahead and make another one.
Done?